Hey everyone, welcome back to NADBYTE.com, your go-to channel for automation and industrial control systems. Today, we're diving into an essential and incredibly useful feature in CODESYS, the Recipe Manager. Let's take a real-time example to understand recipe management more clearly. Imagine you're working with a Sprite bottle filling machine on a beverage production line. In this setup, the machine needs to handle different product types and bottle sizes efficiently. Instead of manually changing settings every time you switch products, you can use recipes to store and recall predefined parameters. For example, if you're filling a 500 milliliter Sprite bottle, you can use a recipe called Sprite 500 milliliter, which sets the filling time to 3000 milliseconds, the fill volume to 0.5 liters, and enables auto mode for smooth operation. Similarly, for a 1 liter Sprite bottle, the recipe Sprite 1L would adjust the fill time to 6000 milliseconds and fill volume to 1.0 L. Now let's say you're producing a variant like Sprite 0. The Sprite 0 1L recipe can be used, which has slightly different filling parameters, say a fill time of 6200 milliseconds, but still the same volume of 1 liter. If the production line switches to a flavored version like Sprite Lemon Mint, the Sprite Lemon Mint recipe comes into play. Here, auto mode might be set to false to allow more operator control during the flavoring process. Lastly, for routine maintenance, the Sprite QA clean cycle recipe can trigger a cleaning cycle with just 0.1 liters of water and a short filling time of 1000 milliseconds, again with auto mode turned off. This way, each product variation has a tailored recipe, improving consistency, reducing downtime, and making operations far more efficient. In this tutorial, we'll walk step by step through everything you need to know. How to create a recipe definition. How to assign your PLC variables to the recipe. How to create, save, load, and delete recipes using built-in visualization tools, where recipe files are stored in your runtime system, even on VxWorks or Linux-based targets. How to troubleshoot if recipe files are not getting created, especially in custom builders or non-standard runtimes. And as a bonus, we'll share some hidden tips to ensure your recipes load correctly and persist across reboots. To begin using the recipe functionality in your CODESYS project, the first step is to add the Recipe Manager object. Open your project and go to the device tree. Right-click on your application, select Add Object, and from the list of available objects, choose Recipe Manager. This object acts as the core component that enables recipe handling in your application. Once the Recipe Manager is added, you can now define what variables should be included in your recipe. To do that, right-click on the Recipe Manager in the device tree and select Add Object Recipe Definition. This will create a new recipe definition under the Recipe Manager. You can name this recipe definition anything relevant, like recipes, product config, or based on your machine's operation mode. This is where you'll later add the variables you want to store and restore using recipes. Let's first take a moment to explore the Recipe Manager settings. When you click on the Recipe Manager object in the device tree, you'll notice two important tabs in the editor window, General and Storage. In the General tab, you'll see settings related to how the Recipe Manager behaves at runtime. One of the most useful options here is Auto-Save Recipes. When this is enabled, any changes made to recipe data during runtime are automatically saved without requiring manual intervention. Now switch to the Storage tab. This is where you define how and where the recipe files are saved. A critical setting here is storage type. There are typically two types. 0 equals binary. This saves the recipe in a compact, non-human readable format. 1 equals textual. This stores the recipe in a .txt file, which is easy to read and edit manually. You'll also see fields like file path. This determines where your recipe files will be stored. If you leave it blank, the default path, usually the Pelagic folder, will be used. File extension, usually set to text recipe for textual storage. Token separator defines how values are separated in the file. Common options are =, tab, or comma. Adjusting these options ensures your recipe storage aligns with your system needs, whether you're running on an embedded target, industrial PC, or simulation environment. Before you can add variables to your recipe definition, it's essential to declare those variables in your PLC program. The recipe manager only allows you to include variables that already exist in your application. Let's walk through a quick example. Suppose you're working on a filling machine application. You might declare the following variables inside your main program, PLC PRG, or in a global variable list, GVL. Progr var filling time equals 5,000, time in milliseconds. Fill volume equals 1.25 liters. Auto mode bool equals true, whether the machine runs in auto. Product names, default product, product identifier. After declaring your variables in your program, the next step is to link them to your recipe definition. First, double-click on your recipe definition object, the one you named earlier, like recipes. This opens the recipe editor interface. You'll see a table with columns for variable, data type, default value, and more. To add a variable, click on the first empty row under the variable column. A drop-down or browse button will appear. When you click it, a navigation window opens where you can browse through your entire PLC project's variables, including those declared in your main program, PLC PRG, function blocks, or global variable lists. Just make sure the variable you're adding is relevant to the process you're managing and that it's not declared as constant or read-only. Only writable variables can be used in recipes. Once you select a variable, the data type will auto-populate. You can enter a default value, which acts as the starting value when a recipe is created. Optionally, you can define minimum and maximum values, which act as safety or boundary checks. You can also add comments for clarity, great for teams or for future reference. This setup allows your application to support multiple process variations or product configurations without changing the logic, all through recipe files. Now let's move on to the process of adding a new recipe to our project. First, navigate to the Recipe Manager section where we previously created the recipe definition and added our variables. Inside this section, right-click on the area where recipes are listed and select Add Recipe. You'll be prompted to enter a name for your new recipe. In my case, I'm naming it Filling Water Bottle. Once you confirm the name, a new entry for your recipe will appear in the list. You'll now see all the variables that were previously added in the recipe definition. For demonstration, I've declared a few example variables: filling time, which is set to 5,000 milliseconds, fill volume, which holds a value of 1.25 liters, auto mode, a Boolean flag initially set to true to indicate automatic operation, and product name, a string variable set to default product. In the new recipe entry, you can easily assign different values to each of these variables depending on your application. For instance, if I'm creating a recipe for filling larger bottles, I might change the fill volume to 2.0 and update product name to large bottle. Once the values are entered and saved, it's important to verify that the recipe has been stored properly. For that, log into your PLC, download the application, and then go to the device tree. Expand the File section and navigate to the PLC logic directory. Here, you should find a file named something like recipe.fillingwaterbottle.txt recipe. Select this file and use the left arrow button to copy it from the PLC to your PC. Choose a folder where you'd like to save it, for example, your desktop, and then open it using Notepad or Notepad++. Inside the file, you'll see each of your recipe variables and the values assigned to them. This allows you to verify that everything was stored correctly and that your recipe is ready to use. If you need to update the recipe later, simply log out of the controller, go back into the recipe manager, modify the values you want to change. For example, increase the filling time to 6,000 milliseconds, and then log back in and download the updated application. Navigate again to the PLC logic folder, copy the updated recipe file to your PC, and open it to confirm that the new values have been saved. This process is incredibly helpful when you're managing multiple configurations, such as different bottle sizes or product types, and allows for easy recipe switching and validation in your system. Now let's talk about how to create and work with a recipe manager using visualization in CODESYS. This is especially useful when you want operators or users to interact with recipes through a touchscreen or HMI interface instead of going into the engineering interface. To begin, the first thing we need to ensure is that the recipe management library is included in our project. To do that, go to the application tree, expand your application, and locate the library manager. If the recipe management library is already listed there, you're good to go. If not, right-click and choose Add Library, then search for recipe management in the library repository and include it in your project. Once the library is added, the next step is to add a visualization object to your project. To do this, go back to the device tree, right-click on the application, usually named Application or your custom name, and select Add Object. From the list of available object types, select Visualization and click Add. Give it a meaningful name like Recipe UI. After a few seconds, CODESYS will generate the necessary background structure for visualization. This includes setting up toolboxes on both the left and right panels of the IDE, which makes it easier to design your interface. Next, click on the newly created visualization object in the device tree to open the visualization editor. On the right-hand side of the screen, you'll now see the visualization toolbox, which contains multiple groups such as Basic, Common Controls, Alarm Manager, Trends, and more. For our current purpose of recipe input, we'll focus only on Basic and Common Controls. Now let's start adding elements to our visualization. Begin by navigating to the Common Controls section of the toolbox. From here, drag and drop a text field into the visualization canvas area. This text field will serve as a label and display for one of our variables. Let's say we are showing the auto mode variable. After placing the text field, double-click it to bring up the Properties panel. In the text property, enter a meaningful label, such as Auto Mode Sent D, which allows the value to be dynamically displayed. Next, scroll down to the text variable property. Here, click the button. A pop-up will open. In the Categories panel, choose Variable, then browse and select the variable you want to link, in this case, Auto Mode. This links the field to show live variable data. Now, let's configure how this variable can be modified by user input. In the same Properties panel, find the Input Configuration section. Under On Mouse Click, click the button. In the pop-up dialog that appears, choose Write Variable from the list of actions. Then select the default input mode and confirm with OK. This setup allows the user to click on the field and toggle or input a new value directly on the HMI. You will repeat this same process for each of your recipe variables. For example, if you have variables like filling time, fill volume, and product name, you would drag multiple text fields for each. Assign appropriate labels like filling time sent D, fill volume sent F, and product name sent S. Link them to the correct variables, and set up input interaction using on-mouse click, write variable. Once done, this visualization will serve as your user interface for reading and writing recipe values directly from the device, making your system far more operator-friendly. Once all the visualization elements are in place and your variables are properly linked, it's important to log into CODESYS and start the PLC program. Without logging in and running your project, the visualization canvas won't display or function correctly. Once the application is running, your visualization interface will appear, and you'll be able to see and interact with all the variable fields you just created. You can now update the values directly through the visualization. As you change these variables, you'll notice that the Current Values section of your recipe manager will also reflect the live data, updating in real time with the values you've entered. This tight integration between runtime variables and recipe definitions is what makes CODESYS recipe management so powerful and flexible. Now let's move one step further and discuss how to save and load recipe files directly from the visualization. This allows you to persist recipe data and reuse it later, perfect for machines that need quick product changeovers. To do this, go back to the visualization panel. Under the basic controls in the visualization toolbox, drag and drop a rectangle onto your canvas. This will serve as a button. Once placed, click on the rectangle and go to its properties. Change the text property to something meaningful like Save Recipe As so the user knows its purpose. Next, scroll down to the Input Configuration section and click the Next to On Mouse Click. In the dialog that opens, choose Executable Command. Click the arrow to open the Execute Command settings. In the drop-down labeled Command, choose Save Recipe and File. Once selected, click the plus icon to add parameters for this command. The first parameter should be your recipe definition name, for example, recipes. The second parameter is the name you want for the saved recipe file, for example, water bottle recipe. After entering both parameters, click OK. Now, whenever the operator clicks this rectangle, it will automatically save the current recipe values to a file on the target device. You can repeat this exact process to create a Load Recipe button. Just drag another rectangle into the canvas, label it something like Load Recipe, and configure its on-mouse click the same way. But this time, choose the command Load and Write Recipe from the drop-down. Again, provide the same two parameters, the recipe definition name and the saved recipe file name. This button will then allow the operator to load and apply a stored recipe, writing all its values back into the live variables on the device. This functionality gives users an intuitive and visual way to manage, save, and retrieve recipes without having to touch the underlying code or enter engineering mode. It's a great way to make your automation project more user-friendly and production-ready. Hidden tips: use Save Recipe to archive configurations. Use Load Recipe to restore machine to known good state. Combine with visualization to let operators choose recipes on screen. Store recipes on SD card or USB via placeholder paths like recipes. If you found this video helpful, don't forget to like, subscribe, and visit our website at www.ne.com for more resources and tutorials on C programming and embedded systems. Thanks for watching, and see you in the next video.